For the Elmhurst data, we could write the equation of the least squares regression line as aid hat equals beta naught. Actually, again, the hat probably doesn't belong here because we're using betas and not b's. So the hat always represents something that is a prediction value, but the actual aid would equal the actual beta naught, which is the intercept of the line, the y-intercept, and then beta 1 is the slope, the actual slope, times the family income. So here the equation is set up to predict gift aid based on a student's family income, which would be useful to students considering Elmhurst. These two values, beta naught and beta 1, are the parameters of the regression line. So let me check something really quickly here. Yeah, okay. As before, the parameters are estimated using observed data. So in practice, this estimation is done using a computer in the same way that other estimates like a sample mean can be estimated using a computer or a calculator. However, we can also find the parameter estimates by applying two properties of the least squares line. The slope of the least squares line can be estimated by b1 equals sy divided by sx times r. This is where r is the correlation between the two variables, and sx and sy are the sample standard deviations of the explanatory variable and the response variable respectively. So we will have more information in the next lesson about this variable r. The y-intercept of the least squares line can be estimated by this formula. B naught equals y bar minus b1 times x bar, where x bar and y bar are the sample means of the explanatory and response variables, and b1 is the estimated slope. Here's example 3. Below are the summary statistics for the Elmhurst data. Use the table to find the least squares line for predicting aid based off of family income. So let's start with B1. We have the formula here. So B1 equals SY, which is 5.46, divided by SX, which is 63.2, times R, which is negative 0.499. So this means that B1 is equal to negative 0.0431. So that's an estimate rounded to 3 significant digits. For B naught, we follow this formula. So Y bar, which is 19.94, minus B1, which we just calculated, that is negative 0.0431, times X bar, which we are told is 101.8. So we get an answer of approximately 24.328. So this means that y hat is equal to 24.328 minus 0.0431 times x. So in other words, the prediction for the aid equals 24.328 minus 0.0431 times the income. Here's example 4. It was mentioned earlier that a computer is usually used to compute the least squares line. A summary table based on computer output is shown below for the Elmhurst data. Explain the results of each column. So this first column it contains the point estimates. Okay, this first column also will give us the information we need to construct the equation of the line. So it gives the y-intercept and the slope. The standard error column is always given, so standard error is given always. In other words, we're not calculating that one ourselves. The t-value column, these are the test statistics. And the last column here, these are the p-values. Okay, so if we were to set up hypothesis statements, so we would say the null hypothesis is that beta naught equals 0, or, and the alternative hypothesis is that beta naught does not equal 0. So either the y-intercept equals 0 or the y-intercept does not equal 0. So this is for the top row here. So for the top row, we are testing whether or not the intercept is 0. Oops. Okay, now what about for the second row? For the second row, the null hypothesis would say that beta 1 is 0, and the alternative hypothesis would say that beta 1 is not equal to 0. And so for this second row, or this bottom row, we are testing whether or not the slope is 0. And you can see that the p-values for both of those are so small, they're both less than the significance level of 0.05, that we would be rejecting the null hypotheses for both cases, meaning that we have enough evidence to show that the intercept is not 0, and we also have enough evidence to show that the slope is not 0. Here's example 5. Suppose a high school senior is considering Elmhurst College. Can she simply use the linear equation that we have estimated to calculate her financial aid from the university? Well, the line would have been drawn about right here or so. The line gives you an idea, but it looks like there are more factors for financial aid than just income. So I'll put that down. Here's example 6. The slope and intercept estimates for the Elmhurst data are negative 0.0431 and 24.3. What do these numbers really mean? Well, the slope, which is that first number there, means that for every additional dollar in family income, the student can expect to receive about 4 cents, so $0.04 is 4 cents less in gift aid. So remember, slope is rise over run. So when you're going to interpret a slope, remember that it's the y's over the x's. And so look at the labels of the graph to determine how to interpret this. And so if I put negative 0.0431, I can force that to be a fraction and put it over 1. So this is the aid, and this is the income. Okay, so for every dollar in income, you're getting minus 4 cents in aid. The intercept means that a family with no family income, so zero income, can expect to receive $24,319 in gift aid on average. That's what the intercept means. So the intercept describes the average outcome of y if x equals 0. And the linear model is valid all the way to x equals 0, which in many applications is not the case. So again, many times the y-intercept's interpretation will not make sense because some models don't have data that makes sense when x equals 0. The slope describes the estimated average difference in the y variable if the explanatory variable x for a case happened to be 1 unit larger. So when we describe the interpretation of the slope, here's the language that we can use. For every blank, which is x, we expect blank, which is the y. Okay, so for every dollar in income, we expect 4 cents less in aid. For every centimeter of body length, we expect another however many millimeters of head length, which was another example that we had looked at previously. So try to use this language when you have to interpret a slope. Here's example 7. The graph below shows the number of newspapers delivered and total pay for Leona's newspaper job. What does the slope of this graph represent? So remember, the slope equals rise over run, which is the y's over the x's. So the y's represent total pay, and the x's represent newspapers delivered. Okay, so let's try to measure the rise over the run between 2 points on this graph. So the rise would be 5, and the run would be 5, 10, 15, 20. So 5 over 20 means $5 of total pay for 20 newspapers delivered. Now I could simplify this by dividing the numerator and the denominator by 5, and that would give me 1 over 4. So in other words, she gets $1 for every 4 newspapers delivered. And we could take that a step further and divide the numerator and the denominator by 4, and we would get 0.25 over 1, which means she gets a quarter for every newspaper delivered. Here's example 8. Colby put $100 in a savings account. The graph below shows how the amount in the account would increase over the next 10 years. What do the slope and y-intercept represent? Okay, the y-intercept is the starting amount. So at time 0, Colby had $100 in savings. So that's this point over here. The slope, remember, is the rise over the run. So if I find another point on this graph, which looks like to be over here, then I would rise 50 and I would run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 50 over 10 is the slope, but I have to put labels on these. So the rise is the label dollars, and the run is time in years. So he would earn $50 for every 10 years that he left his $100 in that account. Now we can simplify this by dividing the numerator and the denominator by 10, and we would get 5 in the numerator, which represents $5, and we would get 1 in the denominator, which represents 1 year. So in other words, he's earning interest at a rate of $5 per year. So once again, the slope equals the amount in dollars divided by the time in years. Here's example 9. The linear equation below shows the cost C of a hamburger with different numbers of toppings T. So C hat equals 1.90 plus 0.40 times T. So you might also recognize this format as y equals mx plus b, but it's just switched around where the b is first and the mx is second. So we know that this number right here that's next to the t is the slope, and we know that this number right here in front is the y-intercept. So A says, what is the y-intercept and what does it mean? So the y-intercept is an ordered pair on a graph where the x-coordinate is 0 and the y-coordinate is 1.90 here. This means that if I have 0 toppings, my hamburger will cost $1.90. So this is the cost of a hamburger with 0 toppings. Okay. Part B, what is the slope and what does it mean? So the slope equals 0.40, and I put a little $sign there because 0.40 over 1, okay, well, in C in this case instead of y, but the y-intercept, the y unit is dollars, that's the cost of the hamburger, and the x unit, which is really t in this case, represents toppings. So it's 40 cents for one topping. That's what the slope represents. But in terms of the cost of the entire hamburger, the cost, so let's see, let's write this down. So the cost, let's do this. So the cost goes up 40 cents per topping. Okay. So part C says if Jody paid $3.50 for a hamburger, how many toppings were on her hamburger? So what we would do is we would replace C, which is the cost, with $3.50, and then we would write down equals 1.90 plus 0.40t. and we would solve this equation for t. So we do have to remember some algebra skills in order to do that. To get t by itself, we would start by subtracting 1.90 from both sides. And then we get 1.60 equals 0.40t. After that, we would divide both sides by 0.40. And we get 4 equals t. So in other words, to answer the question, she had 4 toppings. Here's example 10. The regression line for the Burger King menu comparing fat in grams with protein in grams is fat hat, that rhymes, equals 6.8 plus 0.97 times protein. Part A says state and interpret the slope and intercept in the context of the problem. Okay, so the slope, remember, we can put this over 1 to make it into a fraction. So the top is the grams of fat, and the bottom of the fraction is the grams of protein. Okay, so the slope is 0.97 over 1, or just 0.97. You don't have to write it over 1. This means that the fat goes up by 0.97 grams for each additional gram of protein. The intercept is 6.8, or as an ordered pair, that would be 0, 6.8. So 0 represents the grams of protein, and then 6.8 is the grams of fat. So an item with no protein has an average of 6.8 grams of fat. Here's example 10. The regression line for the Burger King menu comparing fat in grams with protein. Okay, we already read that. Part B says, how many grams of fat would you expect for an item with 10 grams of protein? So we would take 6.8 plus 0.97 times 10. So this would give us 16.5 grams of fat on average.